All right, geometry, test 1 through 50 review. This first question is really a matter of how good you are with understanding what a counterexample is. A counterexample is something that meets the hypothesis but does not match the conclusion. Okay? So what they're giving you is they're going to give you a chart with a list of metals on it. Okay? And the statement is going to be, if an element is a metal, then it's solid at 70 degrees Fahrenheit. So what I need to be able to do is I need to be able to look at a list of metals, right, and pick out something that is a metal, right, because that's the hypothesis, right? So, and then I need to find a metal that's on the list that is not solid at room temperature, not solid at 70 degrees, okay? What would a metal have to do in order to be something other than solid at 70 degrees? Melt where? Where in relation to 70 degrees? Before, like somewhere cooler than 70 degrees, or hotter than 70 degrees? Okay, so I heard a bunch of people say hotter. So that's gold, right? And I don't know that this is true. I'm just got it up here. But if gold melts at 1,000 degrees Fahrenheit, what is it at 70 degrees Fahrenheit? Is it solid? If it hasn't, it's not going to melt for another 970 degrees. So what is it at 70 degrees? It's solid, right? So is gold a counterexample to metal being, if an element is a metal, then it's solid? No, it meets the conclusion because gold is also solid at 70 degrees. 70 degrees Fahrenheit is like room temperature, right? I mean, anybody in here own anything that's gold? Yeah, okay, like the ring I've got on is white gold. Okay, it's not super expensive, not incredibly nice. I'm not trying to be impressive. I'm just saying it is. All right, it is by the temperature back here. It's 69 degrees in here, just by what it is. Right, or 74. Do we expect, did this ring melt? All right, at 70 degrees, is it solid? Yeah, okay. What we are looking for is something that has melted before it got to 70 degrees. All right, so if I say I've got metal X up here, its melting point is 30 degrees Fahrenheit. Is it solid at 70 degrees? No. All right. My expectation for you in that box is to say that metal X meets the hypothesis, it is a metal, but it does not meet the conclusion, it's a liquid at 70 degrees. Can we write that? Yes or no? Yeah. Okay, so what I have down here in red is what you should have written down for your notes. Okay? Now, I don't want to take up a terrible amount of time because we have a lot to do and very little time, and I really don't want to do the entire test with nobody in the room. Okay, so I'm going to move on to the next question, okay, because you're going to get this sent to you and all that kind of good stuff. All right, number 2, you're going to get a graph of just a line on a coordinate plane. Your job is going to be write the equation for that line, okay? They want it in y-intercept form. Okay, what's the very first thing that you need to notice about that line? Jarrett? The y-intercept. Okay, then I need to notice the slope. So the first thing I identify is I say b equals -3, and then I count up and over or down and over, depending upon what the graph of the line looks like, to find the slope. What I have in my box there is my work because it's a multiple choice test, right? But what I want to establish is that I understand what parts of the graph I'm looking for in order to write the equation in slope-intercept form. Does that make sense? Yes? No? Because just having this down here, all that shows me is that I can pick an answer from a list. Okay? This shows me that I can read a graph. Does that make sense? Okay, so you guys can do that for me. All right, let's look at question 3. Okay, number 3. You are going to be given a mathematical statement. It is in if-then form. What you are supposed to pick out is the inverse. You're supposed to pick the inverse of that statement. All right? So what is the inverse? And you should be able to read this up here. But what is the inverse of the statement if A, then B? If not A, then not B, right? Okay? So down here, I have an example. I said if a figure is a rectangle, then its diagonals are congruent. The inverse of that statement is if a figure is not a rectangle, then its diagonals are not congruent. Okay? Does that make sense? Okay. What you're going to show me that you understand what an inverse is that you're going to show me this understanding. Okay? You know what a conditional statement looks like, and you know what happens whenever we write the inverse of it. If you can do that, then you should have no problem being able to write this based upon that. Does that make sense? All right, so show me what a conditional statement is, and then show me what happens to it when you write an inverse. Okay, what you see in those 2 red boxes is what you should have down for your work. Everybody follow me so far? Great. All right, number 4. Number 4, what you see in blue is the question. A major arc has a measure of 4x plus 30 degrees. Its corresponding minor arc measures 3x minus 25 degrees. We want to find x. This is all the question is what's written up here in blue. There is no picture. All right? You have to know that if we're talking about arcs, what shape are we using? Are we using trapezoids, rectangles, squares, triangles, or circles? Obviously circles, because that's what's on the board already. All right, what is a major arc plus a minor arc? What does it equal? An entire circle, right? Because it says corresponding major arc, or minor arc plus its corresponding major arc, meaning that they are 2 pieces of a whole that go together. All right, how many degrees are in a circle? 360. Therefore, my major arc, 4x plus 30, plus my minor arc, 3x minus 25, should equal the whole circle, 360 degrees. All right, at this point, I simply combine like terms. 4x plus 3x is 7x. 30 minus 25 is 5. I get 7x plus 5 equals 360. Subtract 5, 7x equals 355, divide by 7. In this case, x equals 50.7. 1, and because they said just find x, I can stop there. All right? If they had said, what is the degree of the major arc, what is the degree of the minor arc, I would need to do what? Plug x back in. Fortunately for you, your x is going to come out to a much nicer, neater number on the test. Okay? Does that make sense? Now, what I could do to make sure that I got it right is go ahead and plug these things back in, see if it does come out to 360, those types of things. So what you see in red, okay, I'm trying to circle everything in red that you need to show in your box sheet. That's the work that you would want to show. Okay, nobody should come away from this not understanding what the expectation is. Okay? All right, next question. Number 5. It's going to give you a statement. It's going to ask you to complete the final statement based upon the law of syllogism. The law of syllogism says, if A, then B, if B, then C, therefore, if A, then C. Okay? What you're going to get is that last sentence, this is true, therefore this is true, right? But you're going to have to look for the therefore part. Okay? Basically, you're going to get this, the question is going to look like this: if A, then B, except it's going to actually give you a statement. If, let's say, B, then C, then it's going to say C, you would have to come up with therefore A. Does that make sense? So what you would want to do as you go through is underline the important parts of each statement and label it. Okay, this is the important part of this statement. I'm going to label that. I'm going to underline it. I'm going to make it A. Right? Then I'm going to look for the next important thing and call that B. Right? And then I'm going to look for what's missing at the end and go back through and see what should be there. Does that make sense? All right? Don't fall asleep today and then be upset with yourself tomorrow because you missed something today. Okay? This would be my work, though, is what you see in the red box. 6. 6 is going to give you a picture of a parallelogram and ask you to find the area. How do I find the area of a parallelogram? Base times height. What is the base of this parallelogram? 36. What's the height of it? 12. What's 36 times 12? In this case, 432. All right, what you see in this blue box would be your work for this question. Okay, everybody following along okay? All right, this next question is the last one. Well, we didn't even get to it as a class. Okay, this is a proof. Okay, it says simplify the expression, justify each step, fill in the missing justifications. Let's, I'll make something similar to it. Let's say 40 plus 5 plus 4. Okay. We'll say 40 plus 5 plus 4 equals, what do they do? Okay. They do 40 plus 4 plus 5. Okay? What allows me to do that? What has happened here? Anybody? What would we call that step? No? Commutative property of addition. Commutative property of addition allows me to move things around when it's all addition. So, okay. All right. After that, let's see. They did. Okay. Okay. Not that we would do it this way, but what's this? What did they do there? Or why? They grouped it. You're right. What do we call that grouping with the parentheses around it? Associative property of addition. Okay. And of course, after that, let's see, they do 40 plus 9. Okay. And we just call that simplify. Okay. And then our answer is 49. So really here, your answer is your answer, okay? What I would like for you to do is to, at the very least, copy that much of it down. Can you do that? Okay? 8. All right, 8, they're going to show you something like this. They're going to say, we've got a baseball diamond here. Let's see. It is a square. Its sides measure 70 feet. Or what is the distance from in a baseball field? Some of you guys play baseball. What is it? No. What is the distance from home plate to first base? 90 feet. All right, so let's just say that now basically they're just saying second and home. The rest of it is in the reading, okay? It's square. We'll say each side measures 90 feet. Okay, standard baseball field. We want to know what is the distance, the straight line distance from home to second base. If the catcher had to throw it from home to second, how far does he have to throw it? Okay, well, what do we know about this distance right here? What is that? 90. What do we know about this distance here? 90. What do we know about this angle here? It's a right angle. Okay, how could I find the distance of that red line? Pythagorean theorem. Okay, so 90 squared plus 90 squared equals c squared. I'm betting this is 810. 90 squared? No. 8100. I was off by 0. Plus 8100. Okay, we got 8100 plus, what is it? 16,200. Okay. Square root 16,200. And we're going to go ahead and take it to the nearest, or to the nearest tenth. So 127.2. What? 0.3. That 2 rounds up. Is that what you're saying? Okay, 127.3 feet. Now, because these are 45, 90 triangles, just so you're aware, it has a 1-to-1 to 1 radical 2 relationship, or x radical 2 relationship. So I could have really simply just done 90 radical 2 and plugged that in my calculator real quick. Do that. See if you get the 127.3. All right, is that a little bit quicker? But you would have to show me 90 radical 2. Okay? So that's where your special right triangle information can make your life easier if you can remember it. Either way, I get the right answer. So if you aren't comfortable or you think you might forget that, do you still have the Pythagorean theorem to work with? You sure do. All right. Number 9. All right. Let's see. All right. Somebody give me a number. No, it's 10 or less. 9. Okay. So let's say we have a 9-sided regular polygon. Okay. Let's see. 1, 2, 3, 4, 5. I'm going to have to divide that up a little bit more. Okay, it's not great, but 1, 2, 3, 4, 5, 6, 7, 8, 9. There we go. Not bad. Okay, so we've got a 9-sided regular figure. The question is, what is the sum of the interior angle measures? And they want us to figure this out by dividing the polygon into triangles. And we want to round our answer to the nearest hundredth. All right, so at this point, what you want to do is you want to pick a point, okay, a vertex on the figure. You want to go to every other point and draw a line back to that point. Okay, now these 2 points are already drawn to there. Do we see that? Okay. So we're going to use those triangles to determine how many interior degrees there are. Because what is each of, do we see these figures here? Right, formed by the red and blue lines. What are they making? What kind of figures are they making? Triangles. All right, where every vertex angle is on the exterior of our polygon, right? Okay, nothing's in the middle. Good. All right, how many of them do I have? 1, 2, 3, 4, 5, 6, 7. Right? I have 7 triangles. How many degrees are in a triangle? Okay, so what kind of math am I going to show if I have 7 triangles? 7 times 180. What's 7 times 180?
1260.
I'm going to trust you and say, so there are 1,260 degrees inside this figure. Okay? The sum of the interior angles is 1,260 degrees. Here's a formula, okay, because the one on the test is not a nonagon. Okay? The formula is you take the number of sides in the figure, you subtract 2 from it, and you multiply it by 180 degrees. Okay? You follow me? So our sides here was 9, right? What's 9 minus 2? 7. 7 times 180. Did it work out the same way? It's a little faster, though, if I know the formula. So you can either show the picture and do this math, or do that equation. Okay? And really, in the end, you get to the same math being done. Okay? You're going to get the same 1260. It's just whether or not you need to show the picture or show me the equation. Okay? Okay, 10. Okay. This is going to give you a triangle. Let's see, it's going to this. Let's see. All right. What are those red lines? The tick marks are important here. What are the red lines on that triangle? They are called medians. Okay? Okay? What is this point of intersection called? Centroid. Good. Okay? Let's see. Let's label this. Let's see. You got A, B, C. Let's call these D, E, F, and G. Okay? Does anybody remember what the relationship of AG to AF? It's 2/3. AG is 2/3 of AF. Okay? Meaning this is that the distance from the vertex to the centroid is 2/3 of the distance of the median. You follow me? Okay, so what they're going to tell you is that AF is 18.5. This is the question. AF equals 18.5. Okay, these are medians. Find AG. If I know that AF is 18.5, how do I find AG? Okay, just so you're aware, this picture and this statement is all the information it's given you. Okay, you won't get this, and this is what you need. Okay, so this is our part of our red box. Okay, we don't know what AG is yet, right? That's what we're trying to find. So can I substitute anything in for AG? No, I can't, right? Because that's what I'm trying to solve for. So AG is 2/3 what? 2/3 times 18.5. Can I do that in my calculator? Can I take 18.5 times 2 divided by 3? What does AG come out to? Yeah, 18.5 is 12.3 repeating. So we would say 12 and 1/3. Okay? Or 12.3 repeating. Okay? All right. Fortunately, your answer is going to come out a little bit neater than that. Can we do this? Can we show that? Great. No, you don't have to draw the triangle. Okay, the triangle is already going to be drawn for you. Okay? What do you need to draw? You need to give me this information in the red box. Okay? Your letters in this question are not going to be the same letters that are shown here. So don't study this so much that you tell me that AG equals 2/3 of AF. Okay? Those aren't the same letters. All right, 11. All right, they're going to give you a parallelogram. So you're going to need to know what you know about parallelograms. Let's try this. R, S, T, U. Okay, so we've got parallelogram. It's going to tell you this is a parallelogram. Let's see. Then we're going to say this is 10x, and this is 4x plus 16. Okay? What do I know about the opposite sides of parallelograms? They're congruent. So what am I going to write here? Okay? Now what? Subtract 4x on both sides. Okay? This is work you can show, correct? Now here's the thing. It says in this question, find RU. What do you need to do? Plug it back in for 10x. Okay? Can you do that? So make sure to plug back in. All right. I'll do questions 12 through 20 without anybody here and get that video to you.